Hi everyone, in this video we continue with another example with the unit circle. So we're told for the angle theta is equal to 330 degrees, determine the reference angle. We're also told to determine the x and y values of where the terminal arm intersects the unit circle. And it says the exact values of the trigonometric ratios. And this should actually say the primary trigonometric ratios, because as you'll discover in future videos, there are actually more trigonometric ratios than the primary trigonometric ratios that we've discussed. So like secant, cosecant, and cotan, but we'll the cotangent, but we'll talk about those in future lessons. So the first thing that we're going to do here is we are going to draw out the angle on the unit circle. So let's label this. Let's first scale our axes. That's 1 unit, this is 1 unit, and this is -1, and this would be -1 as well. So we've got a circle of radius 1. Now, to plot theta being equal to 330 degrees, let's draw the initial arm, which we'll draw to here. And then we will draw the terminal arm. Now the terminal arm, let's see here, it goes, this would be 90 degrees, then 180 degrees, then we'd have 270 degrees, 360 degrees, but we're not quite at 360 degrees, we're actually 30 degrees away from there. So that's about, let's say that it's roughly there. Close enough. This is just estimating. So the first part of it is let's figure out what the reference angle is. Now the reference angle is drawn, it's the acute angle that's drawn from the terminal arm to the x-axis. So it's this angle. So this angle is, since this angle is 330 degrees, and a full rotation would be 360 degrees, the reference angle is 30 degrees. So that reference angle, and let's not draw an arrow just to get, let's just write it as 30 degrees. When we draw an arrow, it makes us think that this angle is positive or negative, but we always define the reference angle to be a positive acute angle. So let's not get that mixed up with directions of angles. Okay, so this angle is 30 degrees. And so our reference angle, let's just say that phi is equal to 360 degrees minus 30 degrees, or sorry, minus 330. And let's use a different color. Red doesn't appear well on the screen. It doesn't appear as nicely on the screen. So let's say that phi is equal to 360 degrees rather. Okay, 360 minus 330 degrees is equal to 30 degrees. You don't have to show that calculation. It's just if you want to see how I did that calculation, here it is. Okay, so next it says it wants us to figure out what the x and y values of where the terminal arm intersects the unit circle. So it wants us to figure out the x and the y values where the terminal arm intersects the unit circle. So it wants us to figure out what this x value is and what this y value is. And to do so, let's think about some distances here. So let's draw a right angle triangle. Where we draw a line from this point of intersection of the terminal arm and the unit circle. And let's think about this. So we know that since this is a unit circle, it has radius 1, so that means that this distance is 1. Now since this angle is 30 degrees and this is 90, that means that this angle right here has to be 60 degrees. Now we have a 30, 60, 90 triangle, which is a special triangle. A special triangle with angles 30, 60, 90. Remember that we talked about this in previous lessons. A 30, 60, 90 triangle. This is 30, this is 60, and this is 90. We talked about this triangle where we had side lengths 1 root 3, 1 root 3 and 2. And we said that any triangle that has these angles is similar to this triangle. And so it should have side lengths in the ratios of 1 to root 3 to 2. So that means that here, the triangle that I've drawn here should have the side lengths in an equivalent ratio. The hypotenuse in the triangle that's on this triangle is equivalent to, or it has distance 1. So the hypotenuse has distance 1. In order to get an equivalent ratio, I need to divide all of the parts of this ratio above by 2. So if I divide root 3 by 2, I get root 3 over 2. And if I divide 1 by 2, I get 1 over 2. So that means that the shortest side length should be of length 1/2. The other leg should have length root 3 over 2, and the hypotenuse should have length 1, which it does based on this diagram. So how is that useful for figuring out what the x and the y values are? Well, the x value is going to be positive, and the distance from this point to this point is going to be it's going to be root 3 over 2. So that means that our x value is root 3 over 2. So x is equal to root 3 over 2, and it's positive because it is located in the fourth quadrant, and x is positive in the fourth quadrant. The y value, well, let's think about this. This distance here is 1/2. Since this distance is 1/2, the y value, which is in the fourth quadrant, is going to be negative. So since the y value is in the fourth quadrant, we'll have the y value being equal to minus 1/2. So this coordinate, the coordinate is root 3 over 2, comma, negative 1/2. So using our angle, we've just figured out what the x and y values are. Next, it wants us to determine the exact values of the primary trigonometric ratios. So recall that the sine of theta, or I guess here we can write the sine of 330 degrees is equal to the y value divided by the radius, and the radius for the unit circle is just 1. So the sine of 330 degrees is just going to be equal to the y value, which is minus 1/2 over 1, which is just negative 1/2. The cosine of 330 degrees is just going to be the x value divided by the radius. The x value is root 3 over 2. And the radius is just 1 here. So we have root 3 over 2 over 1, which is root 3 over 2. And the tangent ratio, so tangent of 330 degrees, is equivalent to the y value, which is minus 1/2 divided by root 3 over 2, so over root 3 over 2, which we could just change to multiplication. This is really division by a fraction is the same thing as multiplication by the reciprocal. So we have that tan of 330 is equal to minus 1/2 times 2 over root 3, which is just going to be equivalent to minus 1 over root 3. And this simplifies to minus root 3 over 3 if we rationalize the denominator. So tan of 330 is minus root 3 over 3. Now, there's actually a quicker way to do this. If you think about the unit circle, the tangent of 330, we could think about what the reference angle is. And since the reference angle is 30 degrees here, we can figure out what the tangent of 30 degrees is, which is 1 over root 3. And then we can add our signs based on what quadrant our angles in. So like, let's say I wanted to to calculate what tangent of 330 degrees is. Well, that's equal to, it's going to be equivalent to the tangent of the reference angle, and the reference angle here is 30 degrees. So tan of 330 is going to be equal to tan of 30 degrees, but we have to think about the sign now, because the tan of 30, the tan of the reference angle, is always going to be positive, because the reference angle is always a positive angle. Tan of 330 is in the fourth quadrant, so the tan of 330 is going to be minus tan of 30 degrees. And now I can just use the 30, 60, 90 triangle to figure out what tan of 330 is. Because I know what tan of 30 degrees is if I use my 30, 60, 90 triangle. Tan of 30 degrees is 1 over root 3. So the tan of 330 is minus 1 over root 3, which is equal to, as we've shown here, minus root 3 over 3 if you rationalize the minus root 3 over 3 if you rationalize the denominator. We're going to look at more examples like this in future lessons.